Well, here we're going to do a two-sided, oh, my mistake. I'll do that probably a few times. Okay, so we're in this graphing calculator Desmos, and actually I guess I should say, you should sign in. So hopefully you've got your account at this point. Sign into it so you can save your work. And now, actually, when you want to type a statement, you should come up here, and when you're in your cell, hit Note, and you've got these double quotes on this side. And so I'd like to do a two-sided hypothesis test of a single proportion. Okay, and then what that entails, and I'll do another note, that's H0, so our null hypothesis. And the typesetting here is not real good, but it'll work. And here we expect the proportion to be equal to some P0 value that we set, or an alternative hypothesis that P is not equal to. Now, I don't have a way to make a not equal sign. So one way you can show not equals is you do a less than and a greater than, like that, and P0. So this is our two-sided alternative. And then once we have that, we need to give it our P0. And so for now, so notice when I'm not doing a label, if I say P0, it does that nice subscripting. And we'll start with 0.4, and when that happens we get the slider thing. If I just hit enter, it goes from -10 to 10, but since I know it's P0 and I'm trying to make a template to make my life easier and so forth, I'm going to click here and say, well, it can be no smaller than 0 and no bigger than 1. And that way, if I want, I can try sliding, but I can also just go back in here and say 0.4, hit enter, and there we have it. So I have my P0. Now from there we need data, and so I'm going to make that a note again and say data. And typically for our data we need successes, and it'll either come in like successes and failures, whatever those happen to be. It might come as n and a probability, but so I'm going to set this template up to be successes and failures. Now, so if I do S, and if you want to leave it as S, that's fine. I think if we need S again, we just need to be careful. But what I'm going to do for this video is go ahead and call it successes now. But you can't. If I just start typing, notice it says add sliders and so forth. So that's not what I want. I need to go up. I need to do a shift and do the underline, and that puts me down into a subscript, and then I finish the word successes like that, and then I'll up arrow to get out of the subscript, and equals, and let's say 8. And so once again, because I gave it a constant, it's asking me what I want it to go between, and so I could say 0, and up on this end, it doesn't matter too much. You could say 10, you could say all sorts of things. For now I'm gonna make it 100 just because. Now what if I came in to do my template and I needed 200? Oh, no big deal. 200, just put it there. And now all of a sudden my slider goes all the way up to 200. So it'll just fix it if you need to. And so there I didn't put in an upper bound that time, and it defaulted to 10. But so, whatever number you need, you can put in there. Failures, so again I do the subscripting thing, and failures come up and say equals, and let's say 17, and again I'll say, well, it has to start at least 0. I hit enter, and notice it put me right up at 17. Okay, so there are my successes and failures, and I need n. N equals, now, and I can see here it's just 8 plus 17, it's 25. Now you could actually do that as a formula with successes plus failures, and that would be fine. But probably, I think I can probably add those just fine. If it is that hard, right, I can just come in here and say, now this is a problem with, and why you probably don't want to write out that whole word successes, but I think for the reference video that's good. And then plus failures. So see, I could always do that, and now it knows n is 25. But again, I'm just going to look at those and say that's 25. And if I needed to real quickly, I could also, this is a calculator, so I could have also, instead of using the variables, which would make it automatic, which would be nice, I can come in here and say 8 plus 17. It is a calculator, right? So I can do those kinds of things. But I'm just going to let it be at 25. I'll put in the 0. And so for a single proportion, that is pretty much the data we're going to have. And then from that data right away, I can come up with p hat. And so again, now I could just say p, but you got to be a little careful. Now this was p0. I could call it p1. I could call it something else. I'm going to go ahead and do my subscript and type hat, p hat, and then come up equals, and we calculate this by taking our number of successes, and I got to do my subscript to get that in there, successes, and then I hit the divide or the slash under the question mark there, and divided by n, and that gives me my p hat of 0.32. Okay, so there, is what I can get from my data. And again, if you're given data in a different order, you could always, say you're just given p hat, you could come in and just give it, and say you're given p hat and n, then you could determine your number of successes and failures from that. Right? If I was given that p hat was 0.32 and I knew n, for successes I could take 0.32 times n up here, and for failures I could take my n minus the successes to get the failures. So this is I'm trying to help you with a template, but depending on how you get your information, you may have to mess a little bit with the data as to how you put it in. Again, you could always just figure out what those things are in another calculator window or something like that, and place it in here. Okay, so that is all our data. And so now what we want to do from that is determine our standard error, make our hypothesized null distribution, and create where our alpha goes. So I'm going to do those things, but I'm going to put a note there that says that's what I'm doing. So let me add a note here. And so we're going to calculate the standard error, the hypothesized distribution, and the alpha lines, so we can see sort of visually where we would reject. And okay, so standard error, single proportion, and I'm going to call that S with a subscript uppercase E for standard error. So you see, I used some of the same letters, right? I had successes and I had standard error, both starting with S. So again, I could do something like S0 here and an S1 down there, and that would be fine. But you can't have them both be S, right? You have to have different names on these things. Okay, so for the standard error hypothesized distribution, we need a square root, so I just start typing SQRT, and when I hit the T it makes the square root sign, and that's P0 times, and so I did an open parenthesis, and 1 minus P0, close parenthesis, and now I'm going to hit the slash for a fraction underneath the question mark, and it automatically put me under there. Now if you have a plus, now this is a multiplication, if I had a plus I'd want to highlight the whole thing before I said I wanted to do a fraction, because it saw multiplication, so it knew it could just put that division underneath all of it. But if it had been a plus, it would have only gone under the right hand side of the sum. So here I need n, and there is my standard error. Okay, so I have that, and then once I have that, I have my hypothesized distribution, and I'm going to call that n, and that is going to be equal to a normal dist, so I just stop at dist, normal distribution, and notice how it's it wants sliders and so forth, and then once I put that t in there, it says, oh, I know what that is, open parenthesis, and it defaults right now, it just made a mean 0, standard deviation of 1, and showed it over here, graphed it. But what I need is a mean of P0. That's our hypothesized distribution, so I do that, and then a standard error of whatever my standard error is. And so with my subscript in there, I do that, and there's a lovely picture. Close that off, hit enter, and there's my hypothesized distribution. Now we'd like a better picture than this. Now notice this goes up to about 4, and let's see, is that, yeah, here it doesn't, there's no quick way that comes to mind to know exactly how tall it's going to be. Now, but it'd be nice to have this sort of get centered, you know, like this, but I'd like to make it wider. So I can go up here, and for one, I'm going to now show you, okay, I'm going to do projector mode so I can see everything much better. Now the x-axis, this thing should always be more or less between 0 and 1. So if I start a little bit to the one side of it, so maybe minus 0, you know, immediately it went way over here, and then point, I don't know, maybe 0.5, and you know, I can kind of see what's going on here. So maybe that's okay. And if any time I come in and I need to feel I need to adjust it, I can do that. And then here I could go a little past 1, like 1.05. And y-axis, you know, it's always going to be above the y-axis, the x-axis. So here, you know, maybe 0.2 looks pretty good. I can see that fine. And then the 4.7, I'll just leave that. That's fine. I'll click out of here. And there is a very nice picture. Now I can still move around on it if I don't really quite like where it's sitting, but that looks pretty good. Pretty well centered. So there is my normal distribution, and I got this nice plot of it, and you know, the red's a fine color. Now we will be changing colors of things. You just go up here, and if I click on that, you know, I could say, oh well, you know, maybe I'd prefer blue, and then say done, and oh, now it's blue. Okay, now I need my alpha lines, and those are at I need 95% inside and 5% on the outside, and it's two-sided, so I need 2.5% on each side. Well, that's our number 1.96, or about 2, but I'm going to use the 1.96. And so to create those lines, I'm just going to say x equals, and I start, and this is much like a confidence interval, which we'll do a template for one of those as well. I start with my P0 and then subtract 1.96 times my standard, and need my subscript, standard error. And there it is. Now that's in blue. You know, maybe I would like it in black or something like that, so I can definitely see it. And we'll, you know, yeah, okay. Now I can highlight that if I want. I could just retype things with a plus, but I can highlight that. And now I have to do a Control C to copy. I can't like do a right click or something like that. So I'm holding down the Control button, hit C, and then when I come down here, I'll say Control V, and there is the same line in a different color, but now I can come in here and say plus. And there are my alpha lines. So if I end up, if my data are anywhere outside of those lines, I'm going to reject the null hypothesis. If my data are inside those lines, I am going to accept my null hypothesis. But I would like to change those colors. I think I'm going to go with black, and click on that one, go with black, and say done. So I can see them pretty well. I've got the numbers right there. Now here's my p hat. It's 0.32, which is right about there. Oh, okay. So I'm going to see, you know, if I get a p-value that's below 0.05, I'm pretty sure I did something wrong, because I'm inside this. I should get a bigger p-value than 0.05. Okay, but there I've made my standard error, my normal distribution, and that plotted that, and then my alpha lines that, if my data are inside here, I accept H0 or fail to reject it, and if it's outside, out here or out here, because it's two-sided, either side, then I'm going to reject H0. Now, so I can see that right now. I can see I should fail to reject H0. Okay, but let's go through and do a p-value, and that actually, we're going to do some somewhat technical things in Desmos, and we'll in order to make a nice picture and to make this automated. So we could do our picture without making it automated, but I think that's a nice thing to do to make it automated. Okay, so in order to do that, what we want to do is determine the probability of our getting our data, or more extreme, and so I need to do that, and I'm going to create another section down here so I can kind of remember what I'm doing, and I'll add a label or a note, and I've actually copied this so I don't have to take so long to type it in, but probability of getting data if the null hypothesis is true, along with a graph of that probability. So I'm going to find, and actually for a moment you might want to grab this and pull it a bit wider. Okay, and possibly you'll want to leave it wider, I don't know, but pull it a little bit wider so we can see what we're typing and all that. So we want to try to get the probability that we would have, that under this distribution, our data, we got a 0.32. How likely was that given this hypothesized distribution based on P0, right? And this is part of the reason I'm having you build this template in Desmos, is so you can really think about what the heck a hypothesis test is doing. We built this normal distribution just like in our simulations, and we're saying, well, we think that's what the population looks like. So if the population looks like that, then how likely could we get the particular data that we have? And so now comes a slightly technical thing. In Excel, we had to use a conditional if statement. We're going to have to do something similar here, and so we'll do that. Okay, and I'm going to name this probability prob. So there's a P, and then I'm going to use the and I used an uppercase P, and so then ROB equals, and now that's the thing, is uppercase is different than lowercase and so forth. But you see, when you start talking about probability and statistics, we have a lot of P's running around here. We have P0, P hat, P the probability, and we're going to have to come up with p-value, which is because we're doing a two-sided, which is different than just this probability. This would be for a one-sided sort of thing, and so you can use lowercase and uppercase p's. You could use these different subscripts, but again, for illustration purposes, I'm writing out longer subscripts so you can just sort of read off what's there. So I want that probability, and we need a conditional statement. because I'm going to have to compute that probability slightly differently depending on what my p hat is. So I'm going to start that, and the way we do that is I make a curly brace to put this conditional if statement in there, and I'm going to ask if P0 is, or sorry, if P hat is below P0. Okay, so I want to know if P, and I do my subscript hat, is less than P0. Okay, and right now it's giving me a 1 because that's a conditional statement. It's asking if it's true or not, and since it's true, it's calling it 1. And I'm going to leave it like that for a moment and come up here to show what we're going to do. So up here, notice we didn't talk about this fine cumulative probability. If I click on that, it automatically fills in from minus infinity to infinity. Well, if I want the probability of my data or more extreme, well, since 0.32 is less than 0.4, what I want to do is I want to find the area over to the left of 0.32, that probability, and so here I could put in P underscore HAT P hat, and notice it then shows me that and shows me right already my probability. I'm inside, right? I've got much more probability here than the alpha stuff that was left outside here. So I've got way more probability than what these lines produce on the outside of those. So now the problem is if P hat was bigger than P0, I wouldn't want this. I would want from P hat to infinity, but there's no way to kind of put that conditional statement in there. Otherwise we could have just used that, and well, and then I need to also get what that probability is and so forth. So we're going to do the same thing but with a command here. So to do a conditional, I first type in what's the condition and then a colon, and then if it's true, what do I want to do? Well, I want to do what I just did up there, and to do that I'll say n, and notice this says CDF, so I'll say dot CDF, and it seems to know what that is. It changed the typesetting, and I'm going to give it well, actually for this, if I want that cumulative from the left over to my number, I truly can just put in P underscore HAT and close that parenthesis, and there we have it, and I see it's 0.207. Okay, well that's not my p-value, that's half my p-value, and I'm already well over 0.05, and of course our picture will be able to see that. And so that's what I do if it's less than that. But if it's greater than that, if p hat's greater than p0, I need to find the area over here, and so the way I'll do that is the same thing. Oops, I need a dot there, dot CDF, open parentheses, but now I need to say P hat. So I do that same thing, but then a comma, and I start typing infinity, but it's IN infin. Now let me try this actually typing the word. Yes. So I type the word infinity. You can actually get away with dropping that very last I. But so I type the word infinity, and there's that. I'll close off that parenthesis, and that's our statement. Now, just to show you kind of what happens, well, I don't think we can get this. Well, here's a nice thing, just temporarily I'll show you. You can always grab these things and move them. I'm not going to keep that move, but whoops, I need to go up here. Now I'm going to change P0 just to show you what happens. So P0 right now is 0.4 and my P hat was 0.32. That as I move this down here, right, my graph moves and so forth, and that probability, now once I hit 0.32, whoops, right there, it's 0.5. And if I were to keep going, it's actually going to start dropping again. So now it gets smaller and smaller because now it's looking at this side, and so this will never be bigger. You should never get a probability bigger than a half from this thing. Well, yeah, that's true. You should never get a probability bigger than a half. Okay, so I need to go back to 0.40, which is what I was working with. So I have that, and I'm going to bring this back down where I had it. And there we go. Okay, so that's a technical kind of thing with with this conditional, but it's really nice. I mean, I can put that condition on it and get that probability. And so then once I have that probability, my p-value, and I'll do an underscore and say value, come back up. Since this is a two-sided test, is just 2 times that, oops, I didn't do my underscores, ROB, just 2 times that, and I see I've got this p-value of 0.414. Now that, actually, I am going to move up here probably right after that. And I would suggest you leave it there, because then you come in, you set your P0, you figure out your data, and then all of a sudden there it is, there's your p-value 0.414. Now, what I'm also asking you to do is try to make a nice pretty picture, and the reason for this is I would like you to have that picture so it reinforces this idea. So in one sense, hey, we're done, we've got the p-value, there it is. But I think it will help your understanding greatly if when you look at a template like this, if you see the picture of what's going on. And so we're going to work on creating a picture, and again, this picture is a little technical in creating the picture, but it's not that bad, and so okay, what I'm going to do, so I'm going to copy and paste something here, and then put it in. We'll talk about it. Okay, so I created this thing called L, and I'm using L for the lower part. And so what I'm doing is I'm saying here, again, notice this is a conditional sort of thing. I only want to plot this curve. So notice it's in blue, just like the original line. I could change that color. I'm not going to bother changing that color at this point, because we're going to do a couple other things. But this, I'm just doing the lower part of this, and it starts at p hat and goes to the left. Okay, so notice that's the x value there is at 0.32. So that's p hat. And then, so this was just a way to plot that curve. So the normal distribution curve, that bell-shaped curve, is called its PDF, or probability density function. And it's just, it has a formula, and you can plot it like any other function. It's an exponential function. And this is what it looks like. And so we have that. And I'm going to plot something similar that does the right half, and I'm going to call it G for greater. So this L is for, it's the lower part, it's the less than, and the G is for the greater than, equals. And I want the same thing, really. So I'm going to copy with a Control C and Control V. But now what I want is a greater than, and then hit equal. And I have that, and notice that one's in green, and so it went here. Okay, well, I'm trying to make a nice shaded picture, and so I needed this. But actually, I don't want both of those. I only really want the one that fits what's happening. And in this case, it's when p hat happens to be less than p0. And so this is the less than p0 one. And so I want it to fit that. So I need to add another type of conditional. Now here's where it's just unfortunate. This is one of the things with technology. To do this conditional, I can't quite do it the same way, as it turns out. And so here, what I want to do is I want to fill in from the x-axis up to my curve here. So that's the L part. I want to fill that in, and that's what this is saying right here. So 0 is less than or equal to y is less than or equal to that L. So see, that's just filling that in, but I only want it to do it if, so this is a conditional thing, if p hat is less than p0, just like up here. So you would think that I could just do it the same sort of way, that I would say open curly brace, p hat less than p0, colon, and then put this statement in, and then close it off. It doesn't work. So here I'll do a Control X to cut that. Now I'll put a colon in and do a paste. And you see I'm getting this warning sign. It doesn't work. Why not? I don't know. It is a different sort of thing. This was just a function, a line, a curve that could be plotted. This is a whole shaded area. So maybe, in order to make this all work, somebody had to make this thing work, and well, so it had to do it differently. I'm not sure why, but it does. And so that looks great. And then though, if p hat was bigger than p0, I would like it to shade this area over here, and so I do something similar to this. So I'm doing a Control C for a copy, Control V, paste. Notice it's the same thing, but here I want it to do this if it's greater than, and notice all of a sudden it doesn't show up. Well, that's because it only plots it if p hat's greater than p0. And if I come up here and again I reduce p0, at some point we should, so see, it changed colors because it was using the different shader. So p0.4, And so we have that. Now, I don't want those two things to show up. So if I just click on them in their circles, they don't show up anymore. Their colors don't show up. And now I can, I'm going to make these both the same color. I'm going to go with green. Okay, so I have some shading going on. I'm not quite done yet because, again, this is a two-sided test. And so since it's a two-sided test, oh, I messed something up here. I just realized. Let's fix that. Notice I said L, but right, it should be G. Sorry about that. That should be G. And again, now it'll be more clear when I change P0 so that it's less than 0.32. Yeah, there, that looks better. I thought it was kind of odd that it was still going the same way, right? It should be this side because we're talking greater than. And so now we'll get back to 0.4, and we have that. So yeah, I needed a G right there, okay, where I had the L, and I needed that to be greater than. Okay, so they're both green. And now what I want to do is, since it's a two-sided test, I want this shaded region to also show up on this side, the symmetry of it. And so I am going to include some things for that. And so I'm going to call this the opposite tail. And so if I hit enter and make this a note, and then again I'll just paste that in, adding in the graph for the opposite tail. Okay, and since we're telling a story, I guess it wouldn't be wrong if that was TALE either. Opposite story, I guess. I don't know, something like that. Okay, so I have that. Now what I want to do is something a lot like this L here. Okay, so I want to plot something very similar to that. It's still going to be the PDF, but the conditional is a little bit different. And so I'm going to highlight that, Control C, copy, Control V, paste. Now I'm going to notice how that gave me a warning because I've got L defined in the two different places. Now I'm going to say opposite. Okay, and now what we need to do is figure out how far we are from P0. So what I want to do is for X greater than, so I do a greater than sign, hit equals, greater than or equal to. Now the question is, how far was this from P0? Well, the distance between P hat and P0 in here is just P0 minus P hat. Okay, that's that distance. So, there's P0 minus P hat. That's the distance between these, but see, then that puts me down here somewhere. I have to add that to P0, so I could say P0 plus all this, but that just makes it 2P0. Okay, and now notice here, let me get rid of that. Notice here that dark blue started way down here and is coming around there, and that's not what I want. But when I put the 2P0, look, it starts right there. And see, that is symmetric across here from where I started this shaded line. So that's my L opposite. And if I take a Control C again to copy it and Control V to paste, well, I have the same thing there, but I'm simply now going to do a subscript and say opposite. And there we have it. Now I'm going to do that in a different color, but I'm going to wait until I also have the G opposite in there. And so for the G opposite, pretty much I can do the same sort of thing. I'm going to highlight that, Control C. Now I'm going to put that right below it, I think. So I just hit enter and came down here. And now I need to go G opposite. And now for the G opposite, this was P hat was up here, so how would I figure out where this is? I would have to take, again, I'd find that distance. Now that distance in that case is P hat minus P0, so it's the negative of what I had done there, but I still add it to let's see, so I still would oh, sorry, not add it, I would subtract it. I had to think about that for a minute. I would subtract that from P0, and in the short of it is you get this same expression 2P0 minus P hat, but I need a less than or equal to. And notice again, so I can see that picture. Okay, now it looks like it's in the wrong place, but that's because P hat's smaller than P0. And then I, once again, Control C, copy this one, Control V, and this is if P hat is bigger, and it's G opposite this time. See, I remembered to put the G in there. And now I want to turn these off because I don't need to see those. And these colors, I want to make them different than the primary side. I want the opposite side to be a different color, so I think I'm gonna I'll make those red and this one red, and done. And there we go. I've made this. There are my alpha lines. I can look at this and see, oh yeah, my actual p-value area way bigger than those alpha lines, and so it is not surprising to me, right? And you can pause the video at any time to put these things in here, but I'm going to come back up to my p-value. There's my p-value, and now notice though, so now I'm going to keep the 0.4, but start messing with my successes and failures to just try to change this. So suppose I had, instead of 8 successes and 17 failures, suppose I had 18. Now notice I have to fix the n here. Okay, so again, this is where you might make it automatic, but I fixed the n. I need to remember to do that. I've got no real good way to tell me that. Now I guess I could always come up here and data, remember, so I'll put data : remember to adjust successes. Now you don't actually need the failures, but hey, why not? Failures, it'll kind of keep you remembering what you're doing, and n. So there you could put a reminder note, remember to do that. And so I changed the n to 35. Now see, my p-value went down. Those areas went down. Now it's down to 0.167. Suppose this was 28. And then all of a sudden I can see it. There's red, there's green. Notice the green is over to the right because now my p-hat is, what is my p-hat? 0.8, which is much bigger than 0.4. And I get my p-value here, which is very, very, very tiny. Okay, I'm going to put that back to 8. Just click down there to, well, click here, I guess. And there we have it. Oh, I didn't remember to fix your end. Be careful. And there's my original picture. And so there we have it. And then, once you have this, well, you can do it as you go. You can, you then, while you're doing it, in order to save it, click on the untitled graph and see it says, well, give me a title, and then save. Okay, I'm not going to actually do that with this, but there we go. Okay, there it is. We'll call that done. It's a pretty long video to get through all that, but it really, once you have an idea what you're doing, it doesn't really take that long to put all this stuff in, and it gives us a very nice picture to check when we're doing this two-sided hypothesis test. I can see what's really going on, and that is very important. Here's my hypothesis 0.4, and that is what made my bell-shaped curve. That and my standard error. Okay, I had to tell it the standard error, and but that makes my bell-shaped curve, and then my data are what make the shaded areas. Okay, so the hypothesis makes the curve, the data make the shaded areas, and of course my alpha level makes my vertical lines, and I can see that I've got much more shaded area. My data go way inside compared to my alphas, and so I know my probability in this distribution, there's going to be a lot more of the population that fits my data than what I need to reject the null hypothesis. So here, I would have to accept the null hypothesis. And you could even put in, I hadn't really planned on that, but you could even put in a note, right? You could go in here and you could say, add a note, p-value less than 0.05, reject H0, and otherwise fail to reject H0. And there you go. Now you got no excuse for forgetting what to do, right? And you've got it right there. You got a beautiful picture. And so what a very nice template, if I do say so myself. Okay, and remember to save it. Okay, we'll call that good.